Hello, everyone. My name is Ashley Kinnaman, and I'll be your operator today. We will begin today's session. On behalf of IDEXL, we take immense pleasure and privilege in welcoming you all to our Amazon AWS Immersion Day, June 2022. In this edition, we will talk about how you can leverage Amazon Rekognition for digital transformational financial services. Today's agenda, the intro to IDEXL. In this section, we will briefly introduce IDEXL and its service offerings, visual IDEXL data extraction services. IDEXL's data extraction services. In this module, we will brief about IDEXL's AIDE. Our solutions can identify, extract, and analyze data from all types of sources at phenomenal speed with tremendous accuracy by harnessing the power of automation and ML. Then we move on to the demo. In this module, we will have a demonstration of IDEXL's extraction tools. Then the computer vision with Amazon Rekognition. In this module, we will provide an intro to computer vision and illustration of how to utilize Amazon Rekognition for computer vision. Then moving on to the Rekognition lab session, building blocks of a good recognition models. In this module, we will offer a guided hands-on lab session on how to apply computer vision techniques using Amazon Rekognition. And then finally, the industry use cases and benefits. Here in this module, we will discuss a few of the industry user cases, benefits, and challenges solved using Amazon Rekognition. Some of these are already included in the AIDE tool. Our company overview. Something about us. IDEXL is a professional services and technology solutions provider headquartered in Herndon, Virginia, with over 20 years of experience in implementing complex technologies. Our esteemed clientele includes commercial clients across industries, public sector, and nonprofits. Our expertise. We are an Amazon Web Services AWS advanced tier service partner specializing in artificial intelligence, machine learning, data services, and cloud services for both commercial and public sector customers. We have over 130 plus AWS certified cloud practitioners, 15 plus AI and ML experts, and 40 plus big data and analytics experts on our team holding various competencies within the AWS ecosystem. We are ISO 27001 certified by British Standards, BSI, for information security management. Next slide, please. Thank you. IDEXL is more focused on supporting the AWS cloud. As you are aware, we are an Amazon Web Services, AWS Advanced Tier Service Partner and Reseller. We achieve AWS competencies in migration, DevOps, and financial services, are an Amazon EC2 for Windows Server and Amazon Redshift delivery partner, have attained AWS partnership for providing robust technology solutions, have been recognized as a public sector partner with the authorization to resell and service the AWS government cloud, and are also a preferred partner for the Well-Architected Framework, WAF, partner program, and an Immersion Day partner. Next slide, please. These are the 4 core areas we specialize in with extensive expertise in cloud services, cloud native services, automation and AI, and data platforms and intelligence. Now, let's get to know briefly about our speakers on board. Viswanath is IDEXL's principal data scientist, leading the AI and automation practice. He carries over 8 years of experience in the field of AI and automation. He will walk you through most part of the presentation, apart from working with you on the Rekognition lab session. Sashank is working with IDEXL as a data scientist. He will walk you through the lab session on Amazon Rekognition. Thank you all so much for taking the time. And I will go ahead and turn the call over to Viswanath. Sir, please go ahead.
Thank you so much, Ashley. I think we'll get started with the IDEXL's data extraction services, AIDE. So in this, I'm going to give you a brief walkthrough of what are AIDE's capabilities. So let's begin here. So AIDE stands for Automated Intelligent Data Extraction Tool. Is a solution framework that we have built on top of Amazon TechStrack. It has the following properties. It is completely customizable data extraction framework. We can customize AIDE, provide our customers with only those components that are absolutely required. It can handle any document data type like JPEG, PDF, images, TIFF, TXT, doc formats, the Microsoft doc, or if there are new formats, we would be able to handle them too. Documents that have input, which is either in the form of a printed text or a handwritten text is something that we can handle. Extraction, does not require a template-driven approach. Template variations are handled with these. We can typically handle new templates, within the next day. The important document types that are also automatically classified. We kind of handle these with extremely high accuracy. Our solution is built on top of the Amazon tech stack, which has which has a complete AI stack with several different AI components. Our solution framework, uses technologies like computer vision, natural language processing, and others. Most importantly, our solution also includes Amazon's A2I, which is Amazon's human in the loop framework, where you can route specific documents with lower extraction confidence, or even randomly pass some of the extraction jobs for a human review. You would hear a lot about this, in our solution brief and in the lab session as to how do we equip this human in the loop. Since the solution framework is built on top of Amazon tech stack, it meets the necessary regulatory compliance standards like ISO, PCI, SOC, etc. Most importantly, apart from the initial setup costs that you end up only paying for the necessary resources that you kind of utilize. So significantly cheaper than what's available in the market. Okay, so now now that we have discussed the different features of AIDE, we'll quickly take a look at AIDE in the first place. I hope you can all see my screen, which has the AIDE platform. So this is a demo version of our platform that we have available exclusively for demos like this. So I'm going to click on continue. AIDE has two broad components. Number one is extraction, and number two is redaction. So we'll get started to understand the different extraction capabilities of AIDE. So let's begin with trying to pick up a traditional tax form. As you can see here, the tax form here is a very simple tax form. Ideally, the expected output that we have received from that we have received as a request from our clients is to identify the different keys and the corresponding values. As you can see here, we are able to clearly get all the individual keys and their corresponding values as such. This just took very few seconds. So now let's move on to the next category in the extraction part. So not only can we extract forms, but we can also handle invoice and receipts with these. So now let's just upload a quick invoice. And I'm going to select invoice and receipts. I'm going to click on submit. And you can see the output for the invoices coming up in two different categories. So category one is a summary of outputs, which is a key value pair. And the category two is line items, indicating this different spends that are there that is part of this invoice. You can see this AIDE intelligently divides these two different outputs as two separate sections and provides output in the format. And these outputs are completely customizable. You can choose however you would want, and we would be able to customize this for you. So let's move on to another category. So since we have seen invoice, receipts are very similar. So let's take a look at a very generic form, which is typically used in financial services. So we kind of call this as a generic bank form. I'm going to submit that and try to show to you as to how AIDE extracts. Unlike forms, which has a very clear separation of key value, here, in some cases, the key value is kind of separated in a different way. I mean, there were kind of boxes that were separating it, but here, it's not so clear. But we were able to. You can see that we are able to clearly extract them as key value pairs, and we can show them in the order that it appears in the document. So now let's move on to another category of form called as unstructured forms. Okay, so unstructured forms are long form documents which typically has pages and pages of text in it, but unlike a traditional form, you do not have the key and value very well defined. But here, using Amazon Textract and our intelligent algorithm that we built on top of it, we would be able to literally find the needle in the haystack. Right, we can identify where the key is and where the corresponding value for that key, and you'd be able to see the results now. So I'm just going to quickly open the form because this is slightly different. As you can see here, there are names of some parties. Like this is a typical partnership legal document. So the names of the parties are clearly available here, and there are information about the borrowed amount. There are some dates available, and then the second party who's involved in the partnership is also available in this document. But the problem here is, not all of them are clearly available as key value pairs. You can see that we literally have to understand this to generate those key value pairs. So that's exactly why this is unstructured form. We have categorized this in unstructured form, and the output looks like this. We were able to identify the company that is involved in this partnership, type of partnership, and we saw a dollar figure which indicates some max amount that can be borrowed. It was also able to identify the interest rate and the lending company, also the maturity date and the borrower's name. I think this can be the output over here is only a brief sample of what we can do on unstructured forms, but we can literally customize it to the way in which we would want. I mean, if you as if there are some use cases where you would only need like 3 fields, out of like the 30 fields identified, we can categorically mention that in our post-processing layer to confine it to the necessary fields that's required. Okay, so now let's move on to slightly more complex extraction here. So all the forms that we saw so far are all printed text. Now let's take a look at a handwritten text to see as to how Amazon Textract and our AIDE solution extracts. As you can see here, the sample here, I think let me just submit, and I can show you the input form. So handwritten forms brings in a lot more complexities apart from the traditional form. So number one, you can see the image is scanned. Of course, it has a different color aspect. And you can see the handwritten text is not uniform. It can go in all possible directions. There are also small corrections in the text that is available in some places. So there's like a lot of other complexities that we encounter when we handle handwritten text, but this is just a few of them. And my way of writing certain digits can differ from another person's way of writing certain digits. And some of these forms are financial forms. Extracting the appropriate amount is very, very critical for the overall success of us building the solution. So we've kind of built this in a neat way, and you can see the output is clearly identified with keys and value pairs, and there's no problem at all. We were able to. I think we can further customize it to your requirement and on the type of the form that you're trying to handle, and we would be able to handle this better. Okay, so that's about forms. And there was one unstructured form. Now let's look at the capability of AIDE with traditional text. So I'm going to upload a traditional text. So text-based analytics is very popular, and we can see all of these. I mean, apart from text, all of these also involves certain amount of computer vision that we use, which is built on top of the Amazon Textract, which is naturally available to us. So here's the input text here. The input text is pretty easily read, and it's a printed text. In this, we can identify objects of interest called as named entity recognition. We can do sentiment analysis. Maybe this is not appropriate for sentiment analysis. We can identify the dominant language. We can also identify personally identifiable information from these texts. So I think that's pretty much on text. We'll now go back to table. I think with table, there is slightly more complexities, and I'll just explain to you what they are. So the first table that we're trying to extract here is kind of a table that is probably from like a research article, but this table is surrounded by a lot of text, right? We have kind of built this to ignore the noise and identify the text amidst this noise. You'll see a typical use case in the lab session of this as to how we can utilize computer vision to identify these tables from documents much more accurately. That's in the future. That's in the future statement. Let's move on to the next example, which is a traditional traditional bank statement. I'm going to select the bank statement. A bank statement is has table, but it's not as straightforward as a table that is available, because a bank statement will have a summary on top, as you can see here, and then there's a table at the bottom. So our focus here is to demonstrate specifically the extraction of table and us generating summary values from those tables. You can see here the name of the bank is identified, like a typical summary of the different types of information that we have on this statement of account. So that's table extraction. In terms of table extraction, there is also another type of table. There are two broad categories. One is table which has a clearly separating lines, which divides the rows and columns. We can take care of both. In fact, the bank statement that you saw did not have clearly separating rows and columns for the for the table identification. So that's also something that is handled very neatly. Okay, now let's move on to redaction. Extraction was the first component. Now let's look at redaction. Now let's look at a very different use case in terms of redaction. So we'll take up a form which we saw. So I'm sure you all agree that there are instances in financial services that some information that is required to be that is of the borrower or the end user is only for some eyes only, which means only specific department within the bank or the lending institution or the financial institution should have access to this type of information. So that's exactly where redaction comes into picture. You would be able to kind of redact the information before you pass the information from one to another. So I think the document that we wanted to process is a handwritten form here. That's input already, and I would want to choose the redacted information appear to me as a PDF, or I can choose CSV too, but I'll keep it as PDF now. And I'll choose what information that I want to redact. Looks like account number is a sensitive information, and I don't want other departments in my institution to see this detail of the customer. So I'm going to select this and submit for redaction, and this will be delivered to me as an email in my mailbox. I'm just going to quickly jump to my mailbox, and it should be here in a moment. Okay, here you go. So the information is redacted, and the redacted information is available to you in the PDF, just like this. As you can see here, specifically the account number is what we chose to redact, and the account number is blinded for anybody else to see. I think this is the capability that we have. Like I discussed in the redaction screen, We can either choose to have the output as a PDF or as a CSV. In this case, we thought we should choose a PDF. Okay, now let's look at one last piece of redaction here. Now this is text-based redaction. I think this is plain text. I'm going to have it redacted. Just give me a moment. I'll enter my ID, submit, and here you go. So the information from the input is already available here. And from this, I just want to choose specific fields that I want to redact. Okay, I'm going to choose all of them because all of them appear to be sensitive. And for you to kind of relate, this was the information, the name, address, and phone is an information that is dynamically identified, which is part of the document based on the, based on the previous example that I show where we had PII information that's being redacted. So if you can see here, we have identified what are the different PII information that is required to be redacted, and we are highlighting. And once we click on submit, here you go, the redacted text appears right beside the original text. So there's several use cases that that has this, like banks, or financial institutions use this all the time. I think, I hope this is useful for all of you. So that's AIDE. I think we covered both extraction and redaction. I think we'll be, let's switch back to the slide now. I think before we end the discussion on AIDE, we just have a quick overview of the architecture that is involved in building AIDE, and how we would be able to customize this for any requirement, based on our customers. So our architecture is in fact remarkably simple. The text extraction engine to identify text is, like I mentioned, is built with Amazon TextRack. That's precisely our OCR engine. In the input side, the customer can let us know based on the data volume. We can choose the email to be directly from input directly from an email, or it can be from a stored content like S3 bucket, or the users. We can also build this within the customer's application directly, and we would be able to call AIDE using an API where the users upload the document in the UI directly, and we kind of get the information of the file that is uploaded via the API. And that's the different formats of input that we have. And once we process the document, if the request for the user is to process in real time, we can create the output response as a output response to the API call that calls our service, and it's delivered as a payload, or we would be able to respond back in an email, like you saw in the example of redaction, where the input was from the UI, and we diverted the output, in the form of email. We could also deliver the output into an S3 bucket or a shared drive based on requirement from the customer. Okay, so that's the input and output piece. I think now let's look at, as we discussed, AWS TextRack is at the center, and we have two custom layers that we have built, which is the pre-processing layer, which takes care of the output, and there's a post-processing layer after the output. Now, this is the crux of our solution here. The pre-processing is completely customizable. And why do we need the pre-processing? Let's talk about it for a minute. The reason why we need a pre-processing layer is to ensure, to make the document as purified as possible from a TextRack perspective, and it makes TextRack's life easy. I mean, we kind of get the result that is absolutely intended, and that way we kind of have the control of what we get the output from TextRack. So the same goes with the post-processing as well. Once TextRack extracts, for instance, if we have a date variable, and if you want, if the downstream application requires a date in a specific format, we would be able to convert the date as to how to extract identifiers from the input document into the format in which the downstream application would want to use. Like that's the advantage that we have of a post-processing layer as such. So this provides extreme flexibility and customization that we can do. And on top of this, we also have incorporated human in the loop, where we kind of notify the user using a SNS or ACS service. Once the extraction is completed, and if the threshold of the confidence of extraction is below a certain level, or if if the customer wants us to send random number of documents to the end user for review, we could also do that. And so yeah, that's AIDE, completely Dockerized in a container, and we would be able to deploy it in AWS and provide the API, or it can sit along with your already modernized application sitting in the cloud. So that's precisely how we can deploy. It's very easy to integrate, as we discussed before, and so let's move on. So I think I'll take a pause for any questions, if there is any, for about a minute before we move on to the next section.
As a kind reminder, if you are in Zoom, please use the Q&A pod on the lower right of your screen, or the command box if you're using LinkedIn Live. Thank you, sir. At this time, we will kindly go through the first upcoming poll. Give it about a minute or so for everyone to go ahead and review and respond. Thank you all so much for answering the poll. It looks like you are leaning towards yes, that you are using a data extraction program like AIDE mentioned in the previous slides.
Okay, I think we can move on to the next section of the presentation. So now in this part of the presentation, I'm going to introduce you all some basic concepts in computer vision. I hope it helps you understand computer vision in much more detail. So the idea here is to help you understand at a conceptual level, and then help you also understand what Rekognition's capabilities are. And immediately after this, we'll take you to the lab session to show you how we are helping companies, or how we are helping organizations to apply digitization using Amazon Rekognition. So let's get started. I think we'll first talk about computer vision. So what is computer vision? It's precisely it's an area in the vast field of computer science, which involves which kind of tries to mimic the complexities of human vision system, and we kind of enable the computers to identify and process objects, whether in images or videos, which are nothing but frames of images, just like how a human would react to either effect. One of the primary objective of the field, I believe, is that it enables computers and systems to derive meaningful quantified information from these images and videos, or any or any type of input. I mean, this vision is one of the primary part of input that humans use, right? And one of the driving factor behind the growth of the computer vision is the vast amount of data that we generate as we live every day. That kind of helps us to train and make computer vision in general much better. So computer vision has actually gained a lot of significance in the recent years with the recent advancements in computation power and the amount of data that's available. Um, we'll just look at a broad set of computer vision applications. I think the most prominent one is document extraction, which is information extraction from documents. I think AIDE is a testimony for that. We saw different types of documents and how we are extracting the information from those documents. Computer vision, has kind of derailed the traditional OCR to a point where it is literally pointless for us to go back and use the traditional OCR software. And if there's an OCR, that should be purely driven by AI and ML, specifically computer vision, being at the forefront of it. I think you saw all of these, in the examples discussed above. And one popular example that I could think of is, when you kind of give a table information for a traditional OCR, it cannot understand that there's actually a table. I mean, it'll just extract like a stream of text, which makes it useless for a downstream application, right? Another popular one, which is the new era of mobility that we're getting towards using computer vision, is the application of computer vision in autonomous vehicles. Computer vision enables self-driving cars to kind of make sense of their surroundings. There are cameras, and of course, there are also additional sensors that are there along with cameras. But eventually, even these sensors try to capture the visual aspect of the environment that it is driving through. For instance, it can find traffic signals. It can identify other cars or other objects, or even pedestrians who are walking on the road. The self-driving car can use all of these inputs feed that is coming to it and steer the vehicle, on its way on the streets or on the streets. And the main objective with which autonomous vehicle are usually trained is to avoid hitting, obviously, another car or any obstacles that is on the road. And it is ensure that its primary objective is to ensure the safety of its passenger, and it should take a passenger from point A to point B, which is defined by the passenger. Okay, so the next example that I really want to talk about, and you're going to see a use case which we have incorporated, is facial recognition. Facial recognition is extremely popular, and computer vision plays a big role in facial recognition application. This is typically the technology part that enables for computer to identify who's who. And computer vision algorithms, it works by identifying the facial features in images and compare them against against the earlier identified images in a database, and kind of helps us to do authentication if the identity of the person is the same or not. So a lot of applications today use this. I'm sure a lot of the iPhone users would definitely recollect that every time they open their phone, there's a facial recognition system that runs natively on iPhone, identifying whether it's you who's using the phone. Photography and videography are areas which is literally where computer vision is prominent. In fact, the modern photo, I believe we should call it as a computational photo. It's just not the raw, it's just not the raw, photo that we take from our iPhones and Android. There's literally a lot of algorithms that's running in the background, performing the computations that are required to make the photograph look at its best, and then is when it's given as the output to the phone user. Same applies with videos. In fact, videos videos taken from a phone now have the capability which I mean, there's like depth effect and a lot of other things that are involved. I mean, that are created of, in the videos that are created from phones. It just makes it look like it's shot in it's shot in a high-end camera. And one of the most prominent areas which I believe computer vision is making a significant mark is healthcare, especially the medical image analysis component of healthcare. Computer vision has been a part of advances in health tech for a very long time, but now with the advancements of the algorithms, it can help automate tasks such as detecting cancerous cells in images, or it can find symptoms, of pneumonia. And it was prominently used at the time of in the recent pandemic, where X-rays, just X-rays of members was given to computer vision algorithms, and it was able to identify at the significant accuracy of the percentage of infection of COVID. Okay, before I move further, this is one of my favorite quotes about computer vision from the well-known Fifi Lee. She is a prominent member in the computer vision community, and in fact, in general, in the AI and ML community. So she says that if we want machines to think, we need to teach them to see. And I just love this. The simplicity of putting this through is phenomenal. Okay, let's move on to the next slide, which talks about and gives a comparison of traditional versus modern computer vision. So it's been, like I mentioned, it's been there for a very long time. And in fact, modern computer vision is nothing but deep learning. It's just as simple as that. Okay, so computer vision experiments was there back in 1960s and 70s. It was ideally used earlier to distinguish between typed and handwritten text. That was the major application in which computer vision was there. And then came facial recognition and other things that are other experiments that was running in silos. And kind of computer vision kind of lost its touch during the AI winter, which was a brief period in time and history where AI advancement was significantly stopped because of some misconceptions and also the non-availability of the computing power that we have in our hands today. Okay, so let's look at the image that's over here. Where for us to identify the difference between the traditional and the modern approach. In the traditional method, there was a dedicated, there should be a dedicated code that should be written. So let's say we have an image of a cat, and we have to write a dedicated code to identify and detect specific parts to see whether there's a cat in the photo or not. For instance, there should be a condition that should be written to check if there are 4 limbs for the cat. There should be another program to identify whether there is a prominent tail-like thing in the image, and then the cat's ears, which is triangular in shape. And of course, if you look at more closely, there should be separate program that should be written to identify if there are whiskers around its lips and mouth as such. And we just have to we just have to also identify. We have to say whether it's a yes or no, of the different objects, and basis that we can then classify yes, there's a cat, or no, there's no cat, if based on the conditions that is met. Okay, now we just spoke about the different components, right? The different programs to identify ears, tails, and limbs. Now these are called as features, and it is traditionally represented as a vector in the before being passed to identify whether it's a cat or not. And so that's how traditional computer vision was there. But now let's take a look at how deep learning works. This is significantly different, right? In a deep learning approach, you send the entire raw pixel to neural nets, which there are different types of neural net. We'll talk about it. And when you send that to the neural net, it kind of builds a features on its own. When there are like several images of the cat that are sent across, the neural net will try to build the features of its own rather than us explicitly coding them, right? At a high level, I think it kind of creates the features that are required, and it can identify whether it's a cat or not. And just to kind of introduce, there are two types of broadly two types of there are also other types, but broadly two important types of ML, which is supervised or unsupervised. Those with the target is called a supervised, and the phase in which we build the model is called as training the model. We kind of train the computer to identify whether there's a cat or not, right? So that's called as training. And during the training phase, the data is usually split into, train set and the validation set. Okay, and let's move on further. I mean, ideally, looking at all this, right? Computer vision is all about, pattern recognition. We just see for patterns in the image, and then we decide, which category does the image belong to. And if you give thousands or hundreds and sometimes even millions of images, these patterns would be learned by the network by itself. We just don't have to teach them. I mean, and then when you pass in a new image, it can with a very high accuracy identify if the object of interest is available or not. Okay, let's move on to quickly understand the different types of computer vision. I think the first one that I would want to talk about is the second image here, which talks about which is classification, right? What broad category of object is available in the image or video is classification. And if you have like hundreds of pictures, and if you want to identify whether there is a dog or a cat, that's classification. I think within classification, there's also another operation that is usually done for single objects called as a localization, localizing where the object of interest is. That's precisely what it is. And then we have object detection, which is for us to identify what are the different objects that are there in the in the image or the video, and specifically produce outputs which are called as bounding boxes. And you'll hear this term a lot in further slides and in the lab session. Ideally, the bounding box of the different objects. So this is the two primary ones, and then let's move on to the next one. This very interesting component called as segmentation. Segmentation, as the word says, is for us to segment the image and say what belongs to what, right? So there are two types of segmentation, semantic and instance. In semantic segmentation, you kind of train the model to classify every pixel in the image into one or more target classes. So for instance, in the image, which is on the leftmost side, there are 4 classes. The green pixels all belong to the grass. The yellow pixels belong to the cat. The pink belongs to the trees, and the blue belongs to the sky. So that's semantic segmentation. I mean, you do this classification of the individual pixels, to say which class it belongs to. That's semantic. There's a small variation of semantic segmentation, which is called as instance segmentation. Here, the objective is for us to identify the object of interest and clearly say, count the number of instances. For instance, this is the rightmost image here. Here, the objective is for us to identify the number of dogs and number of cats. You can see dog 1 is red and dog 2 is green. I mean, we can clearly see that there are 2 instances of the class dog, and there's just 1 instance of the class cat. So that's the different computer vision types that we have. So how did computer vision become so popular? Now let's talk about the advancements in the algorithm that is involved in computer vision. This is the chart of the ImageNet large-scale visual recognition challenge called as ILS-VRC, and we are trying to showcase the top 5 errors. And this is a challenge in the computer vision which involves like object detection and image classification at a very, very large scale, which is 1,000 at a very large scale, which is 1,000 plus classes. And the chart here, kind of gives a comparison of how the top 5 error rate. So the top 5 error rate is a fraction of the test images for which the correct label is amongst the top 5%. I mean, um, top five predictions. Like that's what this talks about. So let's say if it predicts, 5 classes, and if the target or the actual class that is supposed to predict, if it is there in the top 5 predictions, is what is the measure here. Okay, so 5%, 5.1% that is there over here is generally, considered to be the error rate if a human is involved in performing the task manually. And yeah, I think that's like a benchmark, right? As you can see, back in 2010, NEC was able to build a model which was able to have the top 5 error rate at 28.19%. I mean, nearly 30%. In 2011, Xerox beat this to 26%, or sorry, slightly below 26%. And then in 2012 is where the first deep learning based architecture model was bought in. And you can see the significant improvement that it has bought in. I mean, right from 25, it moved to 15%, 15% plus. In 2013, a slightly improved version of AlexNet was introduced, which was ZF model. And in 2014, further improvement that we had was VGG and GoogleNet. Like these two also brought in, slight improvements. So we're almost near the human level of accuracy. And then in 2015 was the biggest breakthrough that we saw in computer vision with the advent of ResNets. ResNets are so popular that we use even today in some of the computer vision tasks. There are different flavors of ResNet, which, I mean, the flavors typically indicate the number of layers of ResNet, and that's the point in which literally the accuracy of deep learning model beat the human accuracy from 2015 onwards. 2016 onwards, we do have other things, but the emphasis of the slide here is to show at what point did we start beating the human accuracy for the ImageNet problem. So that's how the algorithms have evolved. And then let's talk about the data set that helped us to improve these techniques. I think the most popular one is ImageNet. I think ImageNet is a large data set of annotated photographs, specifically built for computer vision research. And then is Cypher10 and Cypher100. Cypher10 is typically a data set that has 10 classes with 6,000 different images per class, and Cypher100 is the same thing with 100 classes, but the number of images per class is slightly less than Cypher100. And then we had MNIST, which is a very, very popular data set for anybody who is taking up MOOC online. One of the first data sets that will be introduced is MNIST. It is nothing but handwritten text, which is a grayscale, I think 28 cross 28 image size, having the digits between 0 to 9. An equivalent of MNIST was Fashion MNIST. Rather than digits here, Fashion MNIST had objects of our clothing accessories, and then came and then the other popular one is MS Coco, which is the Microsoft released common object in context dataset. It's a very large scale object detection and a segmentation dataset. I think it has over 300K images to begin with. And then we had another popular object detection data set called as Pascal VOC. There were probably 2 different variations of it, and yeah, regardless, that's another popular data set that we had. So now a combination of both the data set and the advancements in algorithm really drove the field to where we are as of now. And one of the prominent techniques that was kind of driven during this entire phase is transfer learning. Transfer learning is really the biggest. It's really the biggest boon when it comes to deep learning and computer vision per se. It's also there in natural language processing. It's also very prominent in natural language processing now. But just to understand, right? It, it's it is a technique through which the knowledge that is gained by solving one problem can be used for us to solve another problem. For example, if for example, if we have trained a model for us to distinguish, a lot of cars, the same model can be used for us to distinguish trucks too. I mean, just the task here is different, but both are vehicles, right? I think what the machine tries to learn in the first task, which is identifying the wheels, identifying the bonnet and other components, can be translated for it to identify objects in a truck. So that's probably a simple example that I can identify of transfer learning. And why is it so important, and why are we even talking about it? Because today, we don't have to train models from scratch. If you're able to, for most of the use cases, if you're able to apply transfer learning, we'd be able to save significant amount of time and resources, from having to train deep learning models from, deep learning model from scratch. It's far more efficient than, with just few training time, we would be able to reach the accuracy that we can't even think about, without using transfer learning. So that's exactly how, we should, transfer learning is so important. A quick note though, is that you should choose the appropriate model, which is trained on source task. For instance, if you'd want to if you'd want to build like a text summarization, the source language, the destination language, the destination task language is the same, should be the same as the target task as well. For instance, if you're trying to do summarization in English, you need to pick up language models, that has been trained on English, for you to apply transfer learning successfully. Okay, so that's enough about computer vision and the quick intro that we gave. Now let's talk about Amazon Rekognition. I believe the Amazon Rekognition page describes the tool, the AI service as it can help you to automate image and video analysis with machine learning. And that's what it says, right? So Rekognition provides several computer vision capabilities, which can be broadly divided into kind of two categories. Using those algorithms which are pre-trained on the data that Amazon or the open source or from the different Amazon partners have collected. That's like pre-trained based computer vision models. And the second category is, the algorithms that the users can train on their data set. For instance, like I mentioned to you, if there's a specific use case which is not covered by the Amazon Rekognition, then you can bring in your own data and you can train them on it, right? So the several advantages that we have is using Amazon Rekognition is you can quickly, add like a pre-trained or customizable, computer vision API to your application without building machine learning models, from scratch. You can also, like I mentioned to you, you can also include the human review, like how we have included human review in AIDE. It's very easy to scale. It integrates with other AWS services very easily because it's part of the same cloud and it's a managed service. You end up paying only for the usage that you do as such. That's about it. Nothing extra. Okay, so let's look at the different features of Rekognition. In fact, we're going to look at each one of them in detail in the following sections. So let's jump right to it. So let's talk about the first one. The first one is content moderation. The content moderation feature can detect potentially any unsafe or inappropriate contents across different images and videos. You can use Rekognition the moderation API, either when you're building like a customer support, when you're building like a customer interaction platform, for you to avoid inappropriate images to be posted or inappropriate videos to be posted. Or you can also choose this in your website, or in your advertising. A lot of use cases that we can do. Typically helps to protect the user experience, and of course protect the brand image, right? And there are some instances where you as a brand, or a business as a brand, would have to be aligned to specific regulations, the local or the government regulations, in terms of images or videos to be displayed. And this is a perfect use case for you to use content moderation feature. So today, a lot of companies, kind of does this. Um, but a lot of humans are involved in doing the moderation at using a manual level. But trust me, the speed and quality of you doing using a tool like Amazon Rekognition will be far better in terms of in comparison to a human moderator. Just as we saw that computer vision has already surpassed the human accuracy level, it can also be much more accurate than human moderators. I think most importantly, this kind of lets the brand to focus on what its primary objective is, rather than getting distracted on building models and other activities, which probably is not the best use of the time. As part of the moderation activity, I think the content moderation APIs, which is detect moderation labels. Detect moderation label is for images, and start content moderation is something that can be used for videos. You get like a two-level array with the two-level moderation label as an array with confidence scores. Some of the moderation labels that you get is like explicit nudity, and then you have within that you have different categories like adult toys or nude images and things like that. And then we have suggestive based moderation, which is partial nudity, or the scene having characters with revealing clothes, etc. You can also get moderation labels to avoid a harmful content to be shown to kids, like violence, like physical violence, or weapon-based violence. Or you can also avoid visually disturbing moderation labels to kind of have the kids avoid seeing corpses, or some kind of accidents, or things like that. Drug use moderation, and tobacco or hate symbol is something that is very useful when you're running when you're running ads, or when you're running content, when you produce content from websites. Like all this moderations will kind of help you to ensure that it sticks to the limit that it's supposed to. Okay, let's move on to the next feature, which is a very interesting use case, which is face reduction, comparison, and search. So I think search will cover more about search in the next section, but let's talk about detection and comparison. So Amazon Rekognition kind of helps us to detect faces in images and videos. If you present a image, it can identify whether there's a face or not. And if it identifies a face, it can kind of let you know like what is attributed in the face. For instance, like the position of the eye, like other facial features like nose and your lips and things like that. It can also detect emotions, whether the person that's appearing on the image is happy or sad. You can also compare a face in one image with another face in another image. A quick application that I can think of is the facial recognition system. I think more on it in the demo that we have planned for you. So I think the face recognition system typically determines the the person's face with and it also provides information like the gender and age and facial hair and other characteristics of the face. The most important thing is it kind of gives each of these with a confidence code. So as we discussed here, detect face and compare face are the two important API. And API kind of returns a bounding box. I'm sure you're familiar now with bounding box with the landmark qualities like eyes, nose, and things like that. Like it gives the gender and age and other features as well along with it. So that's face detection and comparison. Comparison typically help you to compare two faces in two different images, and then tell you what is the similarity percentage with a confidence score as well. So let's move on to the next API, which is face detection and analysis. Now this is exhaustive. This is an exhaustive service provided in Amazon Rekognition. This is very useful, and we have used this extensively. So in like how is it different from the previous service? Is that that's more of a identification and just comparison. But here, after we detect, there is a thorough analysis, and so Amazon Rekognition can kind of help you store information about the detected faces, as collections. I mean, we can create collections. We can, if in an office setup, if there are two different types of employees who come in, we can create collections of these employees based on the department, right? You can use the facial information that is stored in the collection to search for known faces in the other images. I mean, this task of us kind of storing the faces is called as indexing the face. So for you to be able to do that, you should first create like a collection, something like collection IT team, collection the data science team, collection testing team, and so on and so forth, where each of the employees that belongs to each of the department will be specifically indexed according to the collection. And you must actually specify the collection manually and let know the algorithm that these are different types of collection. And once you do that, and once the faces are indexed, it can then do the comparison for every time the API is being called. You can do that using the search face by image or start a face search, and of course create stream processor is in terms of videos, specifically stored or streaming videos. You can use it in both the cases. So we can create collections. We can tag members in the collection. We can list the collection, describe the collection, and delete elements from the collection. And the same thing also applies for the different faces. So this is really useful. I think one caution that you should do is you should try to align to the best practices around using this, especially if there's any local law or public public law in terms of using the faces, you should strictly align to that. Okay, that's face detection analysis, and for every collection search, it kind of returns the similarity percentage and the face index or the face ID of where it matches, and of course the confidence score, which is very important, which will kind of help you to determine whether you should consider the recommendation provided by Amazon face detection is appropriate or not. I mean, if it's an environment where you should restrict access, I think I would set the confidence score to 99 and above, and just keep the access very strict. Okay, so let's move on to outside faces. This is general labeling of contents and images. I think we discussed about some of the data set that talks about the different categories. So this is something, this service is something using and open source data or Amazon collected data from its partners for labeling contents, right? So it kind of provides like a high level label detection in images and in videos. A label is typically an object or a person, I mean, in general, a human or an action or even a concept that is found in an image or video, right? For instance, a good example that I could think of is um, you know, like a door, like a house video camera will typically have whether there is cars that is passing before the house, and if there's a human that comes in front of the camera, you can use this to send you an alert whenever there's an object of interest that comes through it. Okay. So collection, I mean, label content identification actually returns a very interesting feature, which provides bounding boxes for the common objects. And yeah, and more importantly, there are 2,500 plus different categories and images, that it can do. But among those, for 200 plus common objects, it can also return the bounding box of the object that is identified in these images. Which is very, very useful. I think, but the number of categories in this label content identification keeps increasing every year with the advancements in the algorithms and the data that we just discussed some time back. Okay, to prominent APIs or detect labels and get label detection. Like I discussed, it returns the list of object labels, some with bounding boxes. I think we the output typically has a list of labels and some with bounding boxes, and of course, the confidence score. It is that is related to the identified object. Okay, so we discussed about label content, but these are general categories and general content. What if your use case is to identify custom labels? For instance, if you are if you're a marketing agency and if you're running an ad campaign, you would want to understand a specific brand logos that has been displayed in the video or in the marketing campaign images, right? So at that point, you cannot use the Amazon Rekognition's pre-trained set of objects and labels. You would have to do custom labeling, and that's exactly what we're going to see now. With the Amazon Rekognition's custom label, you can specify the object in the images based on your business needs. Like I discussed, logo in advertisements is a very prominent use case. You can also include other use cases like in factories for machineries to identify specific machineries and so on and so forth. So developing a custom model to analyze images is a significant undertaking without Amazon Rekognition, because you need a data science team which will require time and expertise and resources to kind of collect the data first, label them, and put significant effort in training the models, and of course evaluating to ensure that it does not have it does not produce wrong predictions. And all of this is kind of made very easy using the UI that's available for Rekognition. So the Amazon Rekognition's custom label kind of extends the Rekognition's existing capability to identify objects, which we discussed earlier, which means it uses transfer learning. I think let's kind of look at the procedure that's involved in doing this using a few screenshots here. So this is a screenshot that you would find once you go to the custom label section. First, you need to create the data set, as in like you need to identify the list of images which should be used to train the model, and then you need to do the labeling. Labeling can be for two types. One is for classifying the images or to identify objects in the images. And then once you do the labeling for all the images that you give as input, you kind of train the model. But before training, Amazon Rekognition will automatically split the data, into a certain percentage It will keep some for training and it will keep some for internal validation for it to teach if the training is accurate enough or not. And it will show you as a metric towards the end, the level of accuracy. And once we train the model, and if the evaluation of the model looks good, and if yes, if the results look satisfactory, we can then look at hosting the model. So this is typically how it done. It is done. You have to go to custom label, first create a project, and you can see I've given a simple name of as detect forms. And once you create the project, you go into the project, and I kind of upload images from my local system. Or you can also take images that are already there sitting in an S3 bucket. And in the step 3, it gives all the images that I've uploaded, and it asks me to kind of label the object that I want. So this is, I'm trying to identify the different names of forms here. This is a use case that you can probably see in Shashank's, lab session. I'm trying to ideally identify, in the image, where is the form number of interest is there for me. It's not an easy task. It's a very challenging task for you to achieve without recognition, but you can do this using recognition. And once you do the labeling, you can begin the model training. Once you begin the model training, it can just the screen will simply indicate that the model is getting trained and training is in progress. And once the training is complete, we would need to create, the, inference pipeline. We can click on, so this is how it looks like, and you click on start. You get something like an ARN, which is the Amazon resource number, which you can typically call in the API. And for every API call, you will get the actual prediction from the custom machine learning model that you've built. So that's custom labels. I hope it's useful. You can see more about it in the upcoming session. So let's move on to text detection now. In text detection, the task here is to identify text from images or stored videos. Once the text is identified in images, we can convert it to machine readable text, because before it has been converted to machine readable text, it's ideally like a text in the image. And recognition can help you identify up to 100 words. That's kind of the limitation that is there as of now. And you can use this feature in a lot of different ways for you to kind of search and retrieve images which has some amount of text. For instance, if you're looking for images which has specific vehicle numbers, you can probably use text detection from those photographs, and for you to pick up those vehicle numbers of interest. That's a very good use case. You can do a lot of filtering in terms of financial service case, where if you see a personally identified information, for instance, like a social security number in any of your image database, you can kind of identify those images, and you can filter those images as well. So that's a good use case as to how text detection can help you and the organization. For you to implement text detection in video, you would have to search for specific text keywords. Something like name in a name that has been displayed in a video stream is something that you can avoid. You can also avoid profanity or specific text in the videos, which is kind of a moderation that we're doing here. And so yeah, I think the APIs for this are pretty straightforward. Detect text and start text detection, and get text detection is for asynchronously identifying text in videos. I think the output that you get is a specific text that is identified. It also kind of gives the text relationship if the two texts are appearing in the same line, and so on and so forth. You can kind of use it appropriately however you need it. After the text has been identified, of course, it gives the bounding box and the confidence scores of the different text that has been identified. Okay, we'll move on to the next service. So this is a cool feature, celebrity recognition. I think mainly used in the advertising world, for them to understand if the celebrity that they, if the celebrity is there in a specific ad or not. I mean, this is a pre-built model from Amazon. They have a growing list of celebrities over 10,000 plus celebrities as of now, and the list keeps growing. Right, there are two primary APIs here. One is recognize celebrities and get the info of the celebrity, and you can run this on both images as well as videos. You can get the name of the celebrity, like their facial features, just like how we saw in the face recognition. Apart from that, you can get the emotion, gender, and of course, everything has a confidence score as well. Okay, the next comes, an interesting, capability, which is video segment detection. So video segment detection, again, can be used by, companies who are running OTT platforms or those who are running similar services like YouTube. It can also be used for educational videos as well, where you can identify specific, technical cues, like if there's a black frame, or if there is, beginning credit or end credit, or any kind of logos as such, and you can typically understand and capture these moments for you to introduce ads, or you can introduce specific video segments based on your need. So that's video segment detection, and so we'll move on to the next service, which is the last service that we're going to cover as part of Rekognition, which is streaming video event detection. This is a very, very useful use case, but kind of not used by a lot. It can help you identify labels, from streaming video, specifically streaming video, to identify specific people, or any people in general, or packages, like your camera facing your front door, or even pets, and yeah, so this requires additional streaming services as well, but it's a fantastic feature for you to use, as such. Okay, so that's Rekognition. I think we have covered exhaustively the different services or the features in Rekognition. We'll take a minute to see if there's any question and answers, and I'll be happy to discuss more those. Thank you.
A kind reminder again, if you are in Zoom, please use the Q&A pod on the lower right of your screen, or the command box if you're using LinkedIn Live. It doesn't appear that there are any questions at this time. We do have a second poll, so we'll go ahead and move on. Please take a moment to answer the question. Thank you all for taking the time to answer the poll. It looks like people are leaning towards they're not sure if they believe that Amazon Rekognition can solve the digital transformation challenge. Move on to the system setup for the lab session. The details of the system setup required for the lab session, along with the necessary code and data, will be shared after the webinar. For those interested, please share your official email IDs in Zoom chat, and those who are connected through LinkedIn Live, please share your official email ID in the LinkedIn Live comments box. There will also be temporary IDs provided for you to try the hands-on lab session, which will be available for use until the end of the day today, June 30th, 2022. I will now turn the call over to Shashank. Sir, please go ahead.
Hi there. Thank you, Ashley. Hi, everyone. A very good morning, and thank you so much for joining this session. We look forward to making it an interesting session for all of you with exciting use cases. So let's go ahead. So, as discussed by Vishwa in the presentation, so this is the home screen. This is the console for Amazon Rekognition, and as you can see, there are various services that are provided by Amazon Rekognition, which are elaborately explained in the presentation by Vishwa. So, few notable things that you can remember are the face comparison API, text and image, API, and also the custom labels. So, as discussed in the custom label slide, we'll be looking at different use cases that will be providing value in financial domain. So let's get on to the first use case. So our first use case will be of an image classification task. So I'm sure you guys remember that we were discussing about a table being present in between the midst of chunk of text, and we want to extract our area of interest is only the data that's present in the table. So as a first step, we want to detect which all pages have a table in a document. So they could be huge documents, and you will want only those pages which have tables in them. So the first use case is to detect which are the pages that have a table in them and which don't have a table in them. So let's get on to the notebook. I will show you a few test images. So this is one test image without the table, and this is a test image with the table. So, and this is without, and this is with the table. So let's get to the notebook. And so we have trained a model on the Rekognition custom label service prior to this webinar that predicts whether a page contains a table or not. And so the model is trained using 24 images of the two classes. One is table and the other is no table. So which is a very small data set, which if you can compare with the traditional deep learning algorithms, you will need lots and lots of data to train a model from scratch. But in this case, like 24 is a training set. So a training set is that set of data which you use initially to make the model learn the features, learn the patterns of the data, and build a model. So and then comes the test set, which is basically used to test the model how it is performing on unseen data. So that's basic. So we have 24 images in the train set for this model. And this code explains this custom label as an image classification task, and this code takes in images as input, and they'll be needed to place in the test images folder. So let's go ahead and look at the code. So Boto3 is the AWS SDK for Python. So it provides a Python API for accessing all AWS infrastructure services. So OS, NGS, and other inbuilt libraries for Python. Pill or Pillow is the image manipulation library, and IPython is an inbuilt library to display the images. Let's look at the first function. This says detect custom labels. So this is the function where the API call to Rekognition happens. And the API that we are hitting in the Rekognition is, which is the custom label service, is detect custom labels. So client is nothing but client is a client is the Rekognition object. It provides us a low-level interface to access this AWS services. And within that, we want to access the Rekognition service. And this client.detect label custom labels. This is where we hit the API. And let us see the request syntax for this API. So as you can see here, the image is one of the mandatory fields, because if you want to perform a classification task, you obviously need an image. And AWS SDK, it takes an image in two formats. Either it needs to be a byte string object, or it can be an S3 object where the image is present in an S3 bucket, and you can give all the details in this. So either of these two options, you can upload an image to the AWS to make the API call. It either needs to be a byte string or an S3 object. And max results is one parameter, one attribute of the request syntax, which you can set to, suppose if you have an object detection task, which you'll look at later. So if you want to limit the number of predictions within one image, you can use this max results. And min confidence is like a threshold. And for every prediction, there's a certain threshold. But if you want to limit this response to only predictions that have a confidence of confidence greater than a certain number, that is where you can set this min confidence attribute. And project version ARN is nothing but an Amazon resource name. So Amazon resource name is unique identification of all the AWS resources. So every AWS resource, every model that you train will have a unique ARN. So it will be a string. So this function basically calls the detect custom labels API and returns as the response. So before, after we pass on these notebooks to you, please ensure that you fill in the access key IDs that are provided to you. So we have already provided a temporary, we will be providing a temporary access IDs, access ID and a secret access ID key. So please ensure you replace these two variables with your particular keys. Let's go ahead. So now we'll just run the cells along with the session. So we're running this, and now image dir is the directory where the test images are present. And as we have discussed, this is the model's ARN, which is nothing but Amazon resource name. You can see it is a string, and it is very specific to the service and the model that has been trained. Minimum confidence, we are setting the threshold to be 75. Let's run the cell, and let us see a sample response for a node table class. So in this, we are loading an image, and then we are hiding the API, and once we get the response, we're just printing it out. So as you can see here, as this is a custom labels API, you can see this part of this response talks about custom labels. So this is basically the custom labels object, which has confidence and a name. Name is nothing but what class this image belongs to. In our case, as it's an image classification task, we have trained the model to detect for two different classes, which is table or no table. So confidence is nothing but how sure the model is that this particular image belongs to no table class. So this custom labels object is what we need to extract in this. Response metadata is the default HTTP headers, and it has the request ID, status codes, and all. So let us look at the sample response for the table class. If you can see, the table class also has the same structure with the custom labels, with the confidence of 80%, saying that okay, this image is a table, belongs to the table class. It has a table in it, and I'm 80% confident about it. So this is the response structure, and now let us test our model on all the images that are there in the test directory. As you can see, it keeps on printing this image name, what is that, and what is the class that is detected. As you can see here, it's been detected as no table. And this image, as it's having a table in it, it's detected table. This is no table again. This has a table. So this is the first step to the extraction, which we have seen in the AIDE services and Vishwa's presentation. That we first need to know which are the pages that have table, and then we can go to the next step of extracting it. So here we have explored the usage of this custom labels for image classification task. Let's go ahead to the next use case. So next one, now we will look at custom labels service for an object detection task. So as we've already discussed in the earlier slides, what object detection is. So object detection involves not only to classify the image as a whole, but it will narrow down the specific place where the object is detected. So let's see a few images. So this is a typical tax form, and in bank and revenue filling offices, we get loads and loads of documents with different types of forms. So not necessarily different documents, but within a document there could be different form types. So this being the scenario, we want to now in our use case we would want to detect only forms of our interest. Not every form is useful for us for our particular requirement. So in this use case, we need to detect form 1040 and form 1120 from a document. So this is the use case, and let's look at the notebook. So the problem statement is that we need to detect whether the page of the document is a 1040 class tax form or a 1120 tax form. So let's this model which is trained, it's trained with 16 images as the train set. Um, and 4 images were in the test set. So let's look at the import statements. Import statements are all same. So let's run the cell. And the display image, this is the function that displays the predictions of the model. So in this object detection task, as mentioned during the presentation, that there will be different bounding boxes that are being predicted. So not just the image, but you will also be able to see where exactly in that particular image that object is detected. So to draw that bounding box on the image, this is what this function does: display image. So if and then once it draws the box in that image, it will return it image. And now we get the detect custom labels function again here. So please ensure that you replace these keys with your particular provided keys. And we are just hitting the API, the detect custom labels, which you have seen in the previous code already, and which is the same request syntax. As you can see, we in this particular scenario, we have provided max results as one of the attribute to detect custom labels. So let's see what the values are. Let us run the cells along with this. So display and this custom labels. And this is the model ARN, and minimum confidence we have set it to 85. So we want each prediction of the box to be prediction of the model to be at least 85% confident. Let us look at a sample response for a 1040 class object. So what we are doing is we read the image and we'll hit the API. We'll pass that image to the API and we'll get the response here. So here you can see custom labels. This is the attribute of our interest. So custom labels object, this contains what is the bounding box that is detected. What is the object that is detected? You can find that in the name attribute. And more details on the prediction is how confidently that particular object has been detected. So we can see it's 98% confident that this box is of class 1040. This is the tax form that belongs to 1040. And geometry is the bounding box. As you can see here, you have height, left, top, and width. So top is nothing but the distance from the topmost corner to the leftmost vertex of the bounding box, and left is nothing but the distance from the left side of the image, left end of the image to the bounding box, to the vertex leftmost bounding box. And this is the class that belongs to that this prediction belongs to. Now let's go ahead and run this on all the images that we have. Just give me a moment. So here we can see the model is able to predict the form 1040 properly. And in the next image, it's able to predict the form 1120. and form 1040 again here, and this is a form 1120. And the next image is again a form 1040 and 1140. So as you can see, the images are of different size, but still the model is able to perform well on all these images. So this is a typical scenario where you can detect the type of forms given given a large document which with hundreds of pages, and you only want to extract certain forms. So this is the object detection scenario that we have covered now. Let's move on to the next use case. I'm sure this will be very interesting for all of you, because this is a very common scenario. The very common scenario that we will be using in our daily lives. So as we already discussed, that while you unlock your iPhones, so it happens just like this in an instant, with the face comparison. So as you can, as you already know that if you want to unlock your iPhone with your particular face, you need to register it first. So we'll now look at the face comparison service of the AWS Rekognition, where we will be comparing two faces and we will say how much similar is the target face with the source face. So let's quickly go into the code. So as you can see, the code, the imports are almost same, except the glob. Glob is just a file path matching library, which is inbuilt in Python. Let's run the cell. And recognition client, this is the client object. So please ensure you provide the keys. You enter the keys that are provided to you here. You replace this part. And this is the compare faces function. So this is the function where the API call to the compare faces component of this recognition happens. So if you look at the request syntax, so we want to call this compare faces API, and we want to pass the source and image. If you look at the request syntax for this, you will see that there's a quality filter. Suppose if in case you want to ignore the images that are of low quality, so you can give a argument of low, medium, and high, or by default, if you don't give it, it will be none. And similarity threshold is, okay, if these two faces, this face is 80% similar to this source face, only then I want the output to be returned. So that is the similarity threshold. And source image, you'll have to give the source image. This is like the reference image that you register in the mobile that you want to use as the compare any other face with. And target image is that image that you want to compare with the source image. So that's the request syntax. And this is a helper function we have written just to help us in loading the particular source image or whatever images we will be loading in this code. So let's go ahead and upload the source image. So I've given the source image and it's loaded successfully into the notebook. And we need to upload a second image in order to hit the API. So let us upload another image, which is of mine, but of a different quality. Let's see how this compare faces API works with, and then we'll run the cell. So in this compare faces API takes in the source images, face and the face to compare. And let's look at the response. I'll just open it in a text editor. So as you can see here, you can see an attribute called face matches. So this is one major, this is the default response metadata is the default one. And another important attribute is source image face and unmatched faces. These are the three major attributes. And in the face matches, as you can see, this is an array. This is not a single element, it's an array. So it is an array of all different face objects. So if you give two images and there are face matches with the source image and with the source face, so you will find that details of the matching face from the target image in the face matches attribute. So in that, they will be present in the form of a face objects. So face object is nothing but it contains the bounding box of the face. So where exactly is the face present in the target image? And this confidence is not to be confused with similarity. Confidence is how confident is the recognition is the face API that there is a face present in this bounding box. So that is the confidence. And landmarks are, as you can see, it's eye left, eye right, mouth left, mouth right, nose, and then all of these are detected within that bounding box wherever that face is located. So pose is these are the rotational axes, and quality is brightness, sharpness, and etc. will be returned. So similarity is where we are most interested in. So this is returned once the target face has some similarity with the source face. As you can see, for both of them being my images, we have a similarity of 99%, 99.98%. So next we'll come to the source image face, and that has the bounding box of the face in the source image, and the confidence that how confident is this um, how confident is AWS that there's a face in this bounding box. So let's go back to the code. So now that we have seen the response syntax, and let's go ahead and run this cell. So in this, now we have this response, and we will just loop over through the response, and we'll say, okay, if there's something in face matches, that means we have found a match with similarity of 99.98%. Now let us compare the source face with a different person's face. Let us load the different person's face. So as you can see, it's a very different image. And now let's compare this source face with the different person's image. And let's print the face matches. So as I said, our attribute of interest would be face matches. And once I run this, you can see that face matches is an empty list because it's not matching. So that's why the system says no similar face detected. If you wish to see the response of the face matches, as you can see here, face matches attribute is empty, and that the different image person's face that has come in the unmatched faces attribute. So all the data that previously we have seen in face matches when the face was matching, now it comes in unmatched faces because they have detected a face, but it is not matching at all. So that's about it. That's about the face comparison API. And this is how simple the face comparison API is. If you want to play around, you can just try replacing this different person image, second image of source and source PNG. All these images, you can try replacing them with your images, and you can run the cells as it is, and you will find the system's output. So let's go on to the next part of the use case. So you must have been familiar with authentication, so OTP authentication. So many of you, while you're trying to log in or make a transaction, you get an OTP from the bank or whoever it is. And once you get an OTP, you have to enter it in the mobile phone, and then you have to verify it, and it's done. So how about we add one more layer of security with the help of face comparison, with help of recognition. So in this notebook, we will look at a scenario where we want to do an in-person verification online. So whenever the person is trying to log in, or probably when we are trying to register for something, and as we'll see a use case later, we'll explain it later in the next part of the session also. So what we want to do in this is the person with whom we want to verify the details, he has to write down the OTP on a white paper, hold it, and then take a picture of it in which his face and the OTP are clearly visible. And this image is what we will take to authenticate and verify the OTP and along with the person. So this will add an additional layer of security for your application, whatever it is. If you want to authenticate, if you want to be more secure in authentication. So this is one very useful, also it's a widely used application. So as you can see, the import statements are all same. We also have imported an extra library here, random. And this is the recognition client object. Please change the keys with your provided keys. And so this particular use case utilizes the text and image API of Rekognition. So let's run the cell. This is the recognition client calls the detect text API, which takes in, we'll look at the response syntax. There are filters that you can provide. If you want to detect text only in a certain section of this image, not the entire image, then you can give this regions of interest. If you want to put a filter on the words that are detected, like minimum bounding box, you don't want to detect very small images that are far away in the image, you can also do that. You can put a minimum bounding box height and width, so that you'll ignore very small, or whatever is your threshold for this minimum height and width and confidence. And then you pass the image. So let's go ahead to the next function. So this is the draw OCR results, which is similar to the previous display results function that we have seen in the previous notebook. So let's run this cell. So what it does is, once the text is detected, it will draw the box over this text, and it will show you, okay, this is where the OTP is there, or OTP is written, and this is the OTP that has been detected. So it will apply OCR on it, and it will get the text in machine readable format. So let's run this cell. And this is the load image function, helper function that we have written to load different images. And authenticate is the, it could be the business logic where you want to, where it takes the OTP verification flag and face verification flag, and it will verify whether, it will check whether both are satisfied or not. It will only allow you when, it will only authenticate you when both are satisfied. This is just the business logic. And generate OTP. So we need, for this demo purpose, we are using a fixed value of OTP, which is 4162. But if you want to play around, you can just uncomment this line, which is, it will give you a 6-digit OTP. And you can take a picture of yourself. You can upload your source face, and you can upload your face, your a picture of yourself holding the paper which has the OTP written in it, and you can play around with this. So for now, let's take the constant OTP. Your OTP is 4162. And now we need to load the image of the person holding this OTP written on a white paper. Let's load that image. So as you can see, it's a very, it's very lightly written. The OTP is very lightly written, and it's not even written with a sketch or a marker pen. It's written with a simple ballpoint pen. And let's see how the response comes for this particular image. So now we call the detect text API for sending this image, and we ask the text and image service to detect the text in it. So as you can see, this is how the response is. So there is a this is the response from the text and image service. As you can see, there are different attributes. The confidence. So how confident is that that the detected text? This is the machine readable text. Whatever is written in this image, it's able to change that to. It's able to detect what is the text that is there, and it will written it in this attribute. So this is one. This is the attribute of our interest, that we'll get the text in the image via this attribute, and this is the confidence of it. Geometry is the bounding box, as we have seen, we have been seeing in the last two notebooks that so this is the bounding box for that particular detected text. And polygon is the vertices. So parent ID is the ID of the line block. So this is a word block. So we are more interested in word blocks because we want to compare it word by word. And that being the response structure, now we will look at the verify OTP function. So it's a simple logic that we will only set the verification flag 1 when we find that this length of the detected text and the OTP are both same. and it's a null. So let us now compare. Let us now get the OTP verification flag for that particular image that we have displayed before. So if you run this cell, you will be able to see that it's able to detect this OTP correctly, even though it is very lightly written and with a ballpoint pen, it's written in a single stroke. It's able to detect it correctly 4162. This is how good this text and image API will work. Now let's compare the face. So now that OTP is verified, now we want to compare the face along with this. So this is the same compare faces function which you have seen in the previous code. And now let us load the source face, given the same face as the source face. And verify face is nothing but the function that that takes in face matches array, and then it will check whether there is any face that has a similarity that has a similarity greater than 90. And if it is there, then we are setting the face verification flag to be true. So let's run this cell again. Okay. Now let us compare the faces now. So as you can see, it's printing matching face found with a similarity of 99.99%. Now, giving this face verification flag and the OTP verification flag, we will run the authenticate function. Now, as you can see, both are success, so authentication is successful. Now, let's see a scenario where the OTP is incorrect. So this is an image with an OTP is written incorrect. If you cannot see it, I'll just read it out for you. It's 416221. So we have written a 6-digit OTP in this. And now let us pass this image to get text and image and then verify OTP, which will return the OTP flag. And after that, we'll pass this same image to the compare faces API, which will compare the face with the source face, and it will return you a face verification flag. So once we run this cell, we'll get the output. So it says OTP verification failed, and hence the authentication has failed. So this is how AWS Rekognition can help in our businesses and in enhancing our security in extraction. So these are very useful use cases in the domain of financial domain. So we hope we were able to help you understand the usage of Rekognition and boost your enthusiasm a bit to experiment with it in the next 12 hours. So thank you so much for the opportunity. Over to you, Ashley.
Thank you so much, sir. At this time, we are going to move on to another Q&A session. If anyone has any questions, again, please use the Q&A pod on the lower right of your screen if you're in Zoom, or the command box if you're in LinkedIn Live. It doesn't look like there are any questions at this time. Okay. Fantastic. Thank you so much. So I will go ahead and turn the call back over. Sir, please go ahead.
Thank you so much, Ashley. I think we already I hope you had fun in looking at the lab sessions that we had for you. So some of these lab sessions are solutions that we've already built. And since we've already covered them in detail, I'm going to briefly explain to you the problem. And of course, the solution is what you saw and what are the benefits. So I'm going to focus on the problem and the benefits. So the problem here, the first use case was facial authentication. The problem here was the request from a customer for increased security and also build, have one system-wide authentication system, which is tamper-proof. And they definitely wanted to include the critical functionalities. So the solution that we showed to you is what we built, and very specifically, this has the benefit of and the customer just mentioned this, right? This is far more efficient than having the users enter the credentials manually, especially for critical authentication tasks. Something like if there is an approval that's coming your way, rather than having something like a password entry, a facial recognition based authentication is far more effective. because it serves two purposes. One, it authenticates and it's extremely fast and easy. Number two, it also takes a photograph as a log, so that which cannot be cheated. So that's how this particular use case has solved one of our customers' problem. So moving to the next one, which is a document classification system. As you can see, as you saw in the example, we have a solution which can clearly classify which tax form it is, clearly identifying which tax form, from the documents that are given by the borrowers to the lenders, will help us to filter, for us to, extract from a particular template, because different tax form will have different information, and the lenders would want only the specific information that they are looking for in each of these tax forms. So this classification kind of helped us, to identify which tax form is there in which page. The main reason that we built this in the problem area is because usually a tax form, right, when it is submitted by a borrower, this comes as one big bunch of PDF, which has like hundreds of pages. And somewhere in those hundreds of pages is the form of interest, that we want will be lying around. Now, identifying that manually is literally impossible, but we were seeking the users to provide the specific pages that they want. And that doesn't sound so good if you have an automated solution. So that's why we implemented the use case that was showed by Shashank in the lab session to identify which page contains what. And this deduction and retrieval. If you have dealt with financial statements, there are some financial statements, which actually comes with a lot of different documents, and a lot of pages, and the table is actually buried within the text, like we saw in the example in the demo. And for you to send all of those pages for a extract to extract will turn out to be extremely expensive. So let's assume on an average you process 10,000 pages per week. And if each document on an average, has 8 pages, where your page of interest is only two pages out of these 8, then the differences in the cost becomes 20,000 pages versus 80,000 pages, which is significant, right? So it is so critical that you identify, which sheet has your specific pages of interest, which will reduce two things. One, of course, it's cost effective, and most importantly, it is time consuming for us, rather than sit and wait for the results, of the extraction in the UI. So this is exactly how some of the problems that we have had is solved using Rekognition. I hope it is a good it's a good precursor for you to go and try Rekognition with the IDs that we're going to provide to you till the end of the day today, EST time. But also feel free to follow us or reach out to us in case you have further questions. We are more than happy to help you. Thank you so much. I'm going to hand over the presentation over to Ashley for the last Q&A section.
Indeed. Again, if you have any questions, please go ahead and use the resources to ask them. And again, it doesn't look like there are any open questions at this time, but if you feel like you want to fill them out, please let us know. But we do have a final poll for you to fill out if you take the time. Just take a moment to review and answer the question, and we'll share the results. Thank you so much for reviewing the poll today. It looks like others was the most answered answer to the question. Are any of the cases mentioned here relevant within your organization? Go ahead and into the poll. And I want to thank everyone for joining us today. This does conclude today's webinar. Thank you so much for joining. Please take care and have a fantastic rest of your day.